A wonderful application of these geometric transformations is computer graphics and computer animation. What we think of animation is really just a bunch of matrix transformations applied to images. It's just a bunch of high-speed linear algebra that's being done. For illustration purposes, just to get the basics across to you, we're going to stick to two-dimensional images or two-dimensional vectors. So we're just going to talk about a vector here with two components, x and y. We have already talked about a variety of 2x2 matrices that are going to do various things. We've talked about stretching matrices, rotation matrices, reflections, projections. All of those 2x2 matrices are great, but unfortunately there is one issue that causes us grief, and that is translation. Translation is shifting. If I have an image in a two-dimensional plane here, we're going to talk about an origin. I would love to be able to shift the origin to a new location. Can I shift the origin to some point P using a matrix transformation? Now, unfortunately, the answer is no, because if I were to take any transformation in this linear form, and if I were to apply it to the zero vector, our origin, no matter what, it will never result in anything but the zero. It will not give me some non-zero vector. If I want to do translation to shift an image to a different location, there's no way that I can do it using these 2D vectors and matrices. So here's the fix. Why are you sticking in 2D? Let's embed this 2D plane into R3. Let's cheat. So I'm going to take the 2D universe that I'm living in. Instead of thinking of it as just a 2D universe, what I'm going to do is think of it as living in one specific plane. And I'm going to take, just for convenience, the plane z equals 1. And so the point that lived here at, let's say, x and y, now this point is going to live at x, y, and 1. So we are just appending an extra dimension to our vectors. We are going to use this form exclusively. These are called homogeneous coordinates. It's going to allow us to save everything that we did with two-dimensional transformations and apply these shifts, apply these translations. This is going to allow us to use our 2D matrices or our 2D effects plus do translation. We are going to perform all of our actions with these 3x3 matrices. Now we've kind of bumped up the dimension. We will always have our 2D action contained in a little sub matrix here. So this is our 2D geometric effect. So rotation or stretching, etc., is going to live there. In the bottom, we will have a row 0, 0, 1. Up here on the side, h and k, and these will be the coordinates of the new origin or our translation. All of our matrices are going to look like this. As an example, if I want to shift the origin to the point h and k, and then I want no effect otherwise, then I'll use the identity in my 2x2 block here. I'll have the new coordinates, and then I'll have a row of 0, 0, and 1. I want to take any point, x, y, 1, and if I do the proper matrix multiplication here, what I'm going to find is that I'll get an x plus h, y plus k, and 1. So I have performed shifting. Yay! So given that, if I want to do multiple effects like a shift and a rotation and a stretch, I can use composition to combine effects. So for example, we talked about a matrix that performs rotation. And so earlier on, we had a rotation matrix, and it had this form cosine of pi over 6, sine of pi over 6, negative sine of pi over 6 here, and a positive. So that would be our 2D rotation. And let's say we want to shift it to a location of -3 and -1. This would be a rotation by pi by 6 counterclockwise, and it would be a translation to -3 and -1. This is a very simplified version of things, but you get the point. It's this breakthrough is to understand the homogeneous coordinates, to bump yourself up to an extra dimension, add that 1, and then you can do everything you want to do in a plane. There's a similar idea for 3 dimensions. You would bump up the dimension and work with 4x4 matrices. So explore the Austin Text and their online website where you can play with this, mess around with 2D animation.